Hello and welcome back to the CCENT journey with me, Ryan, and in this section we're going to start a new topic called the Access Control List, ACLs, and this will be the last topic before we move on to section 5 of the CCENT blueprint. For those who don't know, you can contact me here on YouTube, on LinkedIn or Twitter. So first up, we need to set the scene. We need to understand what is an ACL, an Access Control List. Once we understand what an access control list is, we can then look at actually where we would actually apply that within the network and what we can use it for. So to start up, so it does more than just access. It's more of a way of classifying. So what do I mean by this? Now at the CCENT level, we need to really understand about the access element of an access control list. So an example would be, let's say we have a router and this router is somewhere out onto the internet and you're on a PC somewhere and you would like to SSH to that particular router. Well, what we can do is set up an access control list, and that access control list can determine who can and who cannot access this router for remote management. We can also have access control lists set up where, let's say there's a web server off the back of this router, and down here we have a PC. We can have it where traffic flowing through the router and back out this interface can be denied if it's port 80, but it could be permit if it's port 443. So this is the access element of an ACL. We can use it to control access to a device or access through a device. But what's really important, and that I kind of feel is important anyway, at least at the CCENT level, is to kind of broaden your horizon a little bit and be aware that even though access control lists are primarily used for access, it's more accurate to say that it's used for a classification tool. As you progress down your studies, you'll start to realize that access control lists can be used for many other things, such as, let's say we have a router connected to another router and they're sharing routes. We can have an access control list to determine which routes can or cannot be shared to one another. If we have VoIP set up in the network and that VoIP comes into the router, we can have an access control list to classify that VoIP traffic and give it some sort of quality of service or priority through the network. So sure, at the CCENT level, access control lists are primarily used for accessing a device, either to the device through some sort of management or through the device for the actual data plane. However, it's important to keep in mind that they're more than just the access to a device, it's more of a way for classification. So each access control list has one or more entries, and each of those entries is called an access control entry. So an ACL is simply, as we said, a list, an access control list. And each of those, inside each of these lists, is going to have a bunch of entries. Entry 10, entry 20, entry 30, entry 40, and each one of these is referred to as an ACE. And what happens is as a packet come in, it's actually looked at from a top down. So it will first look at sequence 10 to see if it matches, sequence 20 to see if it matches, sequence 30, sequence 40, and however many more sequences you may have set up inside this access control list. And eventually it will reach the bottom, which is a implicit deny. Now this bit here, very important to remember, and we'll get into what this actually does and what this may mean for you when you're building access control list a little bit later when we jump on to packet tracer. But for now, let's just make sure we understand that an access control list has multiple entries and they're called ACEs. Now, different access lists give different options or abilities. So what do I mean by this? Well, previously I gave an example of a web server and a PC trying to access that web server. And we'd said that on port 80 it was allowed, but on port 443 it wasn't. Well, you'll see that there are different types of access control list, things like standard or extended, and depending on which access control list you create depends on your ability. So do you match on just the source? Can you match on the source and the destination? Can you match on layer 3 or layer 4 information? So it's important to make sure you understand that there are different access lists. Now ACLs uses something called a wildcard, and it looks like the opposite of a subnet mask. So if you remember in the previous videos, we looked at the topic of NAT, network address translation, and I created an access control list with a single entry, and that access control list was simply for the network 192.168.0.0, and the wildcard I gave it, if you remember, was 0.0.0.255, and I said that represents a /24, because if we flip this around and change the zeros to ones and the ones to zeros, we get 255, 255, 2550. So a wildcard is the opposite of a subnet. That's what people say. However, you may be thinking at this point, well, why do we bother with wildcards? Why can't we use a subnet mask? And the reason for that is because, as we know from subnet mask and all the training we've done on them, is we have to have all ones and eventually all zeros. So you can't, for example, have 5 ones, 4 zeros and the rest ones. That's not a valid subnet mask. It has to be either all zeros, all ones, or all ones and then the rest zeros. You can't have it mix and matched. Whereas a wildcard, you can. So what does that actually mean? It means, for example, if I wanted to say, I want you to be 192, 192, I don't care about the second octet, I want the third octet and the fourth octet to both be 0, then we can do that with a wildcard. We can create that match statement, but we can't do that with a subnet mask. Because if we do something like this with a subnet mask, that's not valid. But if we do it with a wildcard, it is valid. So for example, if I wanted a wildcard that matches 192.168.0.0, I could say 0 here, because it has to have 192.168. 255, because I don't care about the bits in the second octet. 00. And what this means is the first octet has to be 192. The third and fourth octets have to be 0. But the second octet can be anything at all. It could be a 1 all the way up to 255. Whereas this power we do not have with a subnet mask. That's why we have these new things called a wildcard. Now at the CCENT level, you don't get into very complex matching. You get very straightforward 0 or 255s. But it's important to understand wildcard in more depth, because if you're looking at an access control list with multiple access control entries, it can get confusing very quickly. Now a lot of access control lists can exist, and many can have a lot of ACEs. Now, even though that sounds obvious, what do I mean by that? Well, you might have a router, and this router might have a bunch of access control lists. So for example, it might have one to control who can SSH into it. It might have another ACL who controls the SNMP. It might have another ACL to control the QoS, another one for routing. It might have one for interface to control the traffic going through, and all of a sudden what we're left with is a really big list of different access control lists. And what's important to understand is you can make as many access control lists as you want to an extent and have a bunch of entries inside those access control lists, but then you have to link those ACLs to the relevant protocols or processes you wish to do. So for example, it won't by default prevent people from SSHing in unless we apply that access control list to a VTY line. It won't stop traffic going through the router unless we apply it to the interface using another command. So it's important to understand that you may have a lot of access control lists. Not all of them needs to be in use, but it can be very messy at times because you have a lot of access control. Now, however, later in the studies, you'll start to realize there are other things. We have things like route maps and prefix list, and these are other types of classification tools that allow us to do classification, and there are different reasons why you would use these over an ACL. This is outside the scope for the CCENT, but it's something to be aware of. So again, something I've already mentioned, different types of access control lists allow different matches. So we need to think about the type of matches and the positioning. So when we create an access control list, maybe we have, for example, let's do this, a router up here, and we have two outbound interfaces with two different servers. Both of these are running port 80, and we have a PC down here, and we want to create an ACL to prevent this PC from going to server 1 but allow it to go to server 2. Well, if we put an access control list here, say in block 80, then it's going to block access to both of these servers. Whereas if we put the access control list here, then when the traffic comes in, it will be blocked from going down to the server 1, but it'll be allowed to go up to server 2. So it's important to understand the positioning of an access control list depending on your network design and what you're trying to achieve. Okay, so let's open up Packet Tracer and grab a device, let's say 2911. Open it up, and let's have a look at creating an access control list very briefly. So we're just going to jump ahead a little bit, and in the next video we're going to jump into different scenarios and how an access list can help us achieve certain scenarios. But for this one, I just want to show you what an access control list looks like inside the actual CLI. So first up, we need to go enable mode or user privileged, config terminal, and we use the IP access list command. Now we have the option of extended and standard, and these are the two that we need to be aware of in the CCENT. And in this case, I'm going to pick standard, and now it's asking me, do I want to give it a name, like for example the name test, or do I want to give it a number? And you can see I have the numbers 1 to 99 available, so I can create an access list number 50. Now this is not the accessed entries, so this is not the actual sequence numbers, this is the name of the access control list. So I'm going to give it the name of a number, which is 50. And then you can see it puts me into this sub configuration mode called Standard ACL. And if we press question mark, we get a few options. Now, first option to talk about is probably the remark. The remark allows you to put some text in there. So for example, we could say remark ACL for VTY access. And the reason for that is because remember I said you can have multiple access lists on a router. Well, it's going to be very tricky to determine which access list is used for what. So we have this option for a remark, allowing us to put almost like a description for that ACL. We then can specify a sequence number, like sequence 10, and then we can say permit, or we can just go straight into permit. And if we don't specify a sequence number, the access control list will give each access control entry their own sequence number. So it depends. Now the reason you may want to specify a sequence number is because if you want to put a match above another entry, you can do that using a sequence number. So for example, let's say I say permit the /24, three entries there. Notice I give none of those entries a sequence, but yet the router is given each of them a sequence which of an increment of 10. So the reason for that is if I now want to put a statement between 20 and 10, I can use obviously sequence 15, 16, 17, 18 or 19. So it is important when you're creating an access control list to give spaces between the entries. Otherwise, if you don't do that, then you will need to modify or delete existing ACEs. Now in some models, in fact most of the newer models, you can actually remap the sequence numbers, but that's outside the scope of the CCENT and I believe the CCNA. But for now, we created an access control list. We have 3 entries. So this says permit the 192.168.00/24, the 192.168.10/24, 192.168.20/24. Now if a packet came in for any other IP range, even the 192.168.30/24, it will be denied. And the reason for that is because if you remember previously I said that there's an implicit deny. Well, now what this means is only permit those 3, everything else is being denied. So we've created access list 50. The problem with access list 50 is it doesn't do anything because it's just sitting there in our running configuration. So we do show run. You can see I've put my remark in, so we know that this access list is going to be used for VTY access, and we're saying that these 3 subnet masks are allowed to connect to the VTY. But again, this is only a description. This doesn't mean that if someone tried Telnet into it now, it will work. For starters, it won't because we haven't set up Telnet, but if we did, we would actually have to apply access list 50 to the right area within the actual CLI or around the actual router. So that's how we create the access control list. Let's put in a sequence. So show access list 50. So notice what I've done here. I've added a deny statement for the 192.168.20/24, and I've done that at sequence 14. Now because an access control list goes top down, if someone on the 192.168.2 network tried accessing this router, again assuming we've set up Telnet, and they're sourcing from this network, because each one of these entries is a source IP address, then anyone on the 192.168.20 network will be denied despite the fact that there's a permit statement at sequence 30, because it's again processed from a top-down approach. So this is why we need to make sure that there are sequence numbers between each of our entries to allow us to input entries above existing ones to override or to maybe become more granular in denying something. So maybe I want to deny a /27 inside sequence 20. So maybe it's 192.168.1 128/27. Then I can deny that in sequence 19, and that would be taken in effect prior to it reaching sequence 20. So that's sort of standard access list. We haven't done anything with it. We've just created it. It's sitting in the running configuration. So again, if we want to do something with it, we have to apply it. So we have to put it on the interface, we have to put it on the VTY line, we have to put it on the SNMP configuration. But for now, it's just sitting there doing nothing. So quickly then, before we end up, what about extended ACLs? So extended, again, notice that we can give it a number or a name. Now one thing that's really important is not, and I'll go into it in a bit more detail, is to remember the numbers. Notice we have number 1 to 99 is standard and 100 to 199 as extended. Now that's not the only ranges. There are other ranges that you can use for standard and extended, because 1 to 99 is simply not enough and 100 to 199 is also not enough. So they bring out with 2 other ranges. Now in reality, unless you're sort of a service provider edge, you wouldn't have that many access control lists. And if you are a service provider edge, you're probably not even using ACLs, you're using something else like a prefix or route policy or something a little bit different there, depending on your equipment. But it is possible to make a lot more access control lists than shown in this. So it's important that you remember the numbers for an access control list. So let's say we make an extended one, we call it 101. Now let's go for permit. Now notice straight away, as soon as I press permit, it's asking me which protocol. So are we permitting based on layer 3 IP? Are we permitting OSPF? Are we looking at particular TCP or UDP ports? So let's say we're going to permit something at TCP. We're going to allow any source, okay, that's allowed to speak towards this /24. Bit too many zeros there. That is equal to, let's say, www or port 80. So what this is saying is anyone for any source is allowed to speak to this /24, providing it's with a destination of port 80. So this is where the extended ACLs come into play. We can use, rather than just a source IP, we can use destination and source IP, and we can also use the port numbers. Okay, so that's all we've got time for in this lesson. Just to touch base on what we've done. We talked about what is an ACL. An ACL stands for Access Control List. We said that an access control list is not just for access, it's more than that. It's actually a method to perform classification, and the main reason for classification at the CCENT level is to control access. But remember, we need to keep our horizons broad in here and make sure we understand that it's not just for access, it's simply a way to classify traffic. We need to make sure that we remember those numbers. So remember I said that 1 to 99 are full standard, and anything above that, so I think it's 100 to 199 is extended. Well, there's even more than this. So there are some newer ranges which are much higher. They're like 1000 or something. Go and read and find out what those ranges are, and also remember those ranges. What numbers can be standard ACLs, which numbers can be extended ACLs. We jumped on to Packet Tracer at the end of the video, and we created a standard access control list, and we created an extended access control list. We didn't attach that to anything. We didn't attach it to VTYLIs. We didn't attach it to interfaces. All we done was created it and left it in the running configuration. What we will do in the next couple of videos is create some access control lists to meet a certain scenario, and then look at how we can apply that and how it affects the traffic going through the network, or how it affects traffic going to devices inside the network. We said that there's a bunch of ACEs, access control entries, that make up an access control list. The access control list is approached in a top-down order of operations. So remember, it goes sequence 10, sequence 20, sequence 30. You could then put sequence 31, sequence 33, sequence 50, sequence 100. But regardless, it's always from a top-down. Once it's gone through all the sequences, if there's no match, there's always a deny at the bottom. So you can't see that deny. If all these statements are permitted, then there's a deny at the bottom. The only way to stop that deny from taking in effect is to obviously permit any on the last sequence. But again, that's something we'll jump into more as we continue with access control list. Now, I hope this video has been informative. I'd like to thank you for viewing, and if it has been, please do like and subscribe.